Okay. Good evening, everyone, and thank you for coming to the Hive Think Tank event. This is the second in series of events on blockchain. The third one is coming up in March. Will be hosted and moderated by Juan Llanos. You probably had the chance to meet him. He's with Coin Analytics, sorry. So, say hi, Juan. Those of you who are tweeting tonight, please just use our Hive Data hashtag or just Twitter handle Hive Data. The Hive Think Tank is the forum for thought leadership. We focus on entrepreneurship and all things data. We are the largest community of data bees. We have in our community around 8,000 data bees. Since our inception, we organized over 150 events and with 200 speakers, and we'd like to thank all of you who attended our events in the past. 2015 was a very successful year for us. These are just some of the speakers that were on the Hive stage. We organized 29 events and we had over 7,000 attendees. Thank you again to all of you who are there with us. For those of you who would like to know what's happening with all the Hive Think Tank events, all of them are posted to our website on hivedata.com. And you can find more information on all of them on our meetup page that you registered through for tonight's event. These are events lined up until June. The next one is taking place again here on Tuesday, March 1st, topic privacy and security in data-driven world. And maybe just to mention that we'll have Fireside Chat with Steve Blank by end of March, but all of them you can find on our website, hivedata.com. Just a big shout out to all our partners and sponsors. Without them, many of our events wouldn't have happened, so thank you to all of them. With this, I'd like just to invite Kamesh to the stage. He's VP of the Hive. He'll share more about the Hive, who we are, and what we do. Thank you.
Thanks, Sasha. Thanks so much for making it Braving 101 and coming all the way up here. As you know, we've been discussing in smaller groups. Hive is an early stage venture capital fund. We invest in data-driven startups which apply artificial intelligence, machine learning, all types of data-driven goodness on very specific verticals. We work very closely with entrepreneurs at a very early stage, enable them to build their company, build their team, build their technology, drive efficiency in engineering so that they can deliver the product and access markets through our kind of community. We look at companies that are primarily focused on IoT, online and enterprise verticals across a bunch of technology areas where we have expertise in-house. Of course, Bitcoin and blockchain technology is one of these, as you can see. We have a couple of companies in that space already. One is Coinalytics. I'm sure most of you would have met Fabio and Juan from Coinalytics who are here. And also Blockstream. So we had an event last week where Adam Back, the president of Blockstream, talked about the sidechain technology. Like all other fast-growing startups, our younger startups are looking to hire and grow their team, expand very rapidly. So in case you're looking for an opportunity to work with early stage startups, do reach out to them. So with that, thanks again for coming here and look forward to engaging with all of you through this event. And with that, I would like to invite Elizabeth Stark and her team who have founded the Lightning Network. They're going to tell us how Bitcoin, which has seen 89 apocalypses and nemesises, and explain why Bitcoin is going to survive those and many more to come.
Awesome, thank you, Kamesh. Hi guys. Yeah, Bitcoin has already died about like 100 times now, but we're still here, so that's really what matters. Awesome, okay. We're here today to talk about Lightning, payments and packets, and the future of blockchain transactions. First, we're going to give a little intro to ourselves. Joseph, we don't want to lose you too much. So we're the Lightning team. My name is Elizabeth Stark.
Hi, I'm Tadge Dryja.
I am Joseph Poon.
And so we'll give a little bit of an introduction on how we got here. My background is in the intersection of law and technology. Have been a big fan of decentralized protocols and open source technology. Yeah, we were going to keep those kit chairs over there. We'll survive. And when I first heard about Bitcoin, I was teaching at Stanford, taught at Stanford and Yale, and a TA of mine sent me an email about this cool new technology called Bitcoin. It was in Wired magazine, and I read it and I thought, oh, open source money, that'll never work. But here we are today, so it actually seems like it's worked far more than we expected it to, and I got really excited about Lightning by meeting these two through the local community. Tadge.
Yep. My involvement in Bitcoin, I read about it in 2011. Was really interested in it, but also was like, well, is it going to work? And so eventually moved to San Francisco in 2014 because this is where everyone was working on Bitcoin. And so I needed to be here. I worked at a company called Mirror, where I was CTO for about a year, and was working on Lightning Network stuff with Joseph and Elizabeth. Started that full-time like last fall.
She also speaks fluent Japanese.
Yeah, I first met, we were talking about doing Lightning for a while. I first thought about a lot of the ideas behind 2013 and sort of presented it in 2013, but there's a lot of iteration, a lot of impetus on that, and we're going to make Bitcoin great again. It'll be great.
We are non-political as a group. All right, Tad, do you want to take it away?
Okay, so I will sort of introduce. Okay, so I don't know what level of how much everyone knows about all this whole blockchain, Bitcoin thing. I'm not exactly sure what the definition of a blockchain is, and I don't think anyone's quite sure yet, but I know how Bitcoin works. And if they're like Bitcoin, one aspect of the blockchain is that everyone's aware of everything. So this is a sort of fundamental security property of like, well, I know the current state of the network, you know the current state of the network, we all have every transaction. As you can imagine, even if you're not into big data and all these things, this doesn't scale very well for everyone to know everything. So currently Bitcoin B can run on a Raspberry Pi, barely, and it's like about 75 gigabytes for the total blockchain, which is not really big data, it's sort of medium data or something that's on a micro SD card. So how would you scale this? This is sort of the biggest topic of debate. Well, currently in Bitcoin, but also since the very beginning. Like when Satoshi Nakamoto, whoever they were, posted October 2008, hey, I'm making this thing called Bitcoin. The first reply on the mailing list was, great idea, it doesn't scale. And so this has sort of been a topic since the very beginning. So yeah, everyone receives every message. It's sort of like if the entire internet were one Wi-Fi access point. So there's sort of this global antenna access point somewhere on the North Pole, and everyone just uses that for all their messages. It doesn't scale well. And also Bitcoin has, to some extent, been oversold because a lot of the conversation about this, year or 2 or 3 ago was that, it's instant and everyone can use it and transactions are free, and those things aren't really true, as people realize once you try to scale this up. It can actually cost money and it actually takes time. So yeah, global consensus is important, but it's inefficient. So one way, if you're all running on the same Wi-Fi access point, is to say, hey, instead of 802.11g, let's use 802.11n or AC, and now we're 5 times faster or 10 times faster. That helps, but not that much, right? You can increase the global data rate of the network, but you still have millions of people trying to compete for the same bandwidth. So traditionally, what you do is you segment the network. You say, okay, I'm not using a hub anymore, I'm using a switch. And I have routers that are aware of this, and hierarchical kind of things. So how can you segment a network? How can you segment a blockchain, but maintain the same security as the global blockchain? So one thing about how these transactions work on Bitcoin's blockchain, if not all, there aren't really accounts, there aren't really balances, there's just transactions. And transactions have inputs and outputs. The inputs are other transactions' outputs. So you're saying, okay, I'm spending these 2 transactions and sending over here. So it actually makes it a lot easier to, it's a little counterintuitive if you're coming from like accounts and balances, but from a computer science perspective, it makes it a lot easier. So you sort of have these if statements where you say like, okay, if someone signs with this public key, they can spend this output. So one way to segment the network is with payment channels. And this is not something we came up with. This is sort of an older idea, but never really got implemented and like sort of fleshed through because of a lot of limitations. The idea of a payment channel is that transactions can be delayed, aggregated, and then settled, sort of posted on the blockchain. So now you only need to do 2 transactions, one to start a channel and one to close a channel. So the idea is, Alice, Bob, they both make a channel together. They can come to consensus on the local state of the channel, and then at some point in the future, broadcast that local state and bring it back to the global consensus. So what's a payment channel? In our system, you have a transaction to start, open the channel, where there's 2 inputs, Alice and Bob, the 2 funders of it, and 1 output, which is a multi-sig address. They both need to sign to spend from it. And then 1 transaction to close the channel, which is 1 input, that output from before, going back to the 2 channel participants. So once you have this, you keep overwriting the closing transaction. And you can adjust that very rapidly without waiting, because there's only 2 people who need to agree on it, so they just exchange signatures, and they can keep track of what our current state of the channel is. So basically the way you revoke olds, the fundamental issue with the channels is previous channels were unidirectional, in that Alice creates a channel with Bob, and Alice has all the money in, let's say 5 Bitcoins. And then Alice can say, okay, Bob, I'm signing off on you getting 1 Bitcoin. Now I'm signing off on you getting 2, on you getting 3. And you can sort of push funds in one direction along the channel. But you can't push the other way, because Bob now has all these signatures. He's got a signature where he gets 1 coin, he got a signature where he gets 2, where he gets 3. And if he tries to say, oh no, Alice, I'm giving you back your money. You now have all 5 Bitcoins. He's still got those old signatures. So he can sort of unilaterally close the channel in the state which benefits him instead of the other guy, instead of Alice. So in Lightning, what you do is you exchange secrets. You use a hash function and you say, okay, if you know the pre-image of this, if you know the secret, you get the money. And what I'll do is to revoke to revoke your claim on it, you exchange the secret, reveal the secret, so you know the other party is not going to try to claim this. So basically, if Alice gets this money if she knows the secret, or B gets this money if he waits a week. So it's a sort of 2-part process where you exchange new signatures on the new state and revoke the old state by revealing secrets. So that's pretty useful. You can open channels, make lots of payments, and then settle later. But it's not actually that useful, right? Because most payments are not metered. If I go to the shoe store, I don't buy 1 shoe, wear it for a day, buy the next shoe, leave. I just buy both shoes. Most payments happen once, and then you might never see that store again for the rest of your life. Or even if it's the grocery store, you go every week. Do you want to pre-allocate your next 6 months worth of grocery spending with the grocery store, and then every time you go, it's not a really good use case, right? There are some use cases where it makes sense for metered kind of things, but in most cases payments don't work that way. So how do you extend a payment channel to these other use cases? So you want a multi-hop network, sort of like the internet, where if there's a channel from Alice to Bob, and a channel from Bob to Carol, Alice wants to be able to pay Carol through Bob. So Bob's sort of this intermediate node. If everyone could route through multiple nodes, this would allow a large high throughput network of payment channels. So you still only need 1 transaction to establish a channel and 1 transaction to close it, but one transaction, Bitcoin does about 250,000 transactions a day at this point. So if you only need 2 transactions per channel, you can do hundreds of thousands of new channels a day, and you can build up a really powerful network pretty quickly. But how do you route this multi-hop network? And if B, the guy in the middle, is trusted, it's easy. And Joseph will show some diagrams.
Okay, so to reiterate, these individual blue lines are payment channels. And to give some color on what's going on, you have blockchain entries. You may be familiar with, okay, there's a ledger entry on the blockchain, and this is your balance, and sort of everybody shares this balance, right? Within this ledger entry on the blockchain, to go over it as a quick review, it requires this cooperation of both your keys and your channel party's keys. So what you see on the actual blockchain for the Alice-Bob channel, the existing Alice-Bob channel, is an output that requires Alice's signature and Bob's signature. So what happens is before you fund the channel, you create a refund. So Alice allocates, let's say, 1 Bitcoin, Bob allocates 1 Bitcoin into this channel. So this channel has an available capacity of 2 Bitcoin, but they locally know who owns which Bitcoin. So initially, Alice has 1, Bob has 1 because they each contributed 1. And before they actually broadcast on the blockchain, they create a receipt, a signature, a transaction, which functions as a receipt that they can broadcast on the blockchain at any time. So what happens is they fund this channel. This channel has two Bitcoin in it. Either at any time, Alice and Bob can broadcast the transaction on the blockchain to close it out. So what happens is that this is not an overlay network and this is not a custodian, right? It's not a system where like you give someone your money and there's this channel. They are exchanging real Bitcoin transactions, and as a result, they can broadcast on the Bitcoin blockchain at any time. So what happens is that Alice and Bob have a ledger entry and Bob and Carol has a ledger entry. So under this model, right, with a network of two-party ledger entries, if you presume, let's say you have 5 and then someone else has 5 and you're connected to them, you can also be able to communicate with those other parties. So maybe Alice has 5 channels, Bob has 5 channels, Carol has 5 channels, and Alice can route to Carol through Bob. And this is just a simplified view, and maybe Alice has 100 channels or whatever it is, but you're only thinking. This is off. Hello? Okay. So how do you pay Alice to Bob to Carol on this network, right? This is all done off-chain and they can update these states locally, but at any time they can broadcast the most recent state on the blockchain because it uses the smart contracting mechanisms. Well, Alice can pay Bob inside this channel, 0.01, and Bob can pay Carol 0.01, right? And they can pay 0.02, and then Carol gets 0.02. And that's pretty simple. You have 0.03. The problem arises when Bob just takes the money, right? Bitcoin's an adversarial environment. Everyone's trying to steal money from each other, and you want to make the system robust against attackers that are out to steal your money. And Bob is an attacker out to steal your money, right? And they decide to keep it. That's a problem, right? Because when you make the signature for the 0.01 payment, they can broadcast on the blockchain, right? You can keep it all off-chain, but because you're signing a real Bitcoin transaction, they're like, okay, great, this is my money now. How do you prevent that? Well, you can design a system that is trustless, and this is what the Lightning Network really does. What happens is if you're the recipient, in this situation, Dave, you generate a random number and then you hash it. Hashing is a one-way function where you produce some data, and it is only that data that can, within some reasonable realm of possibility, be able to produce that hash. So what happens is you produce a hash of, that's the number 1, and it produces this long string. It produces number 2, and it's this other string that looks totally different, right? So what happens is, in order to redeem the funds, you need to know, but you can give H to anyone. Is sort of how hash functions work in this situation. It's sort of like, I don't care who knows H, only I know R. If you know R, consider it paid. And they exchange a signature in order to establish this pay to contract hash. Alice doesn't know R, and Bob doesn't know R, and Alice wants to pay Dave. And Alice wants to pay Dave conditional upon knowing R. So Alice makes a transaction to Bob, and Bob makes a transaction to Carol. Carol makes a transaction to Dave. At this point, Dave can redeem the funds from Carol, because this actual payment is conditional upon knowledge of R, right? So because it's conditional upon knowledge of R, Dave redeems the fund from Carol, Carol redeems the fund from Bob, and Bob redeems the funds from Alice. Now what happens is that by knowing R, you can broadcast the transaction on the blockchain and redeem it. If you don't know R, the transaction times out and refunds. So what happens is, if you really want to know R, because you want to be able to receive the funds. So the funds go through, and the funds actually go through like locked in, off chain. Now you could redeem this on chain by going onto the blockchain and say, I know R, and here's a script that says, it requires R through hashing it to H. But you don't redeem it on chain because it's just easier to settle off chain on this network. But if the other party goes offline, you can always redeem on chain. So the cool thing about this is that by connecting to multiple people, you can route a payment path, through a network of participants, and you sort of don't really care who the intermediaries are. It's like if they don't fulfill their obligation, then the funds don't flow through. It's functionally an atomic system with timeouts, where like you can route through this participant, and this participant, I'm sure they're great people, but like maybe they just go offline, right? Let's say they go offline, and they're sort of like, well, what do I do now? The system still functions through this system of cryptographic timeouts. The interesting thing about this is that the view of the blockchain changes dramatically. The blockchain sort of becomes this court, this dispute mediation system. You have these ledger entries, they're joint ledger entries, and you can exit from this at any time. But you're attesting to a certain state when you exit it. You say, hey, Alice has been talking to Bob for a while, but they've had 2 Bitcoin. The most current state is Alice has 1.5 and Bob has 0.5. Now, what happens is that when you attest to the blockchain, because this is all off-chain, right? The entire point of Bitcoin is to order transactions. That's why you have blocks. That's why you have proof of work. When you have off-chain, you have off-chain ordering. But that order is only enforced when you go back on chain. So when we go back on chain, there's this dispute mediation period, right? So the blockchain acts as programmatic court. It's like a judge that reads a script, similar to how a human judge reads a contract, except it's programmatic, right? It's like the judge is only going to rule one way. So if you act dishonestly, you're going to lose your money, right? But if you act honestly, you're going to get this result. Which is a really different way of looking at blockchains. A lot of people have this view of blockchains as, hey, it's going to be this static thing. We're gonna map an existing system and just shoehorn it in. It's sort of like in the early 90s that everyone was comparing the internet to fax machines, right? It's very, very different dynamic when you look at it along like this layered structured view where you have these people forming these contracts and all these relationships with each other and building up these high volume transactions. Like on this network, you can do like incredibly high volume. But at any time, you can enforce these contracts on chain through these smart contract mechanisms. And Elizabeth will go into more examples of that.
As a friend of ours said, the blockchain is judge, and then the judge can never be bribed, which is pretty cool. So in the end, what we have here with what all we discussed is that ultimately Lightning becomes a protocol for financial transactions. Bitcoin's blockchain, or it can be any others, and we'll get to that in a second, ultimately becomes a batch settlement and clearing mechanism. So you could have, say, millions or billions of off-chain transactions where state is updated locally, and then you finally have the blockchain that clears it. So in the end, you can think of the on-chain transactions as transactions settled per second. Pierre, you're the one that gave me that. Thank you. So that's a good way of thinking of it, and then you have the transactions that are happening in Lightning in between. As per the title of our talk today, these payments or these transactions effectively become like packets are on the internet. And then all of those that are participating on the network, and it could be a phone, it could be a laptop, it could be a server, can become a potential node. Now, of course, if you're using a phone, chances are, well, the phone's going to be off, half the time or something, so it's not going to necessarily be as reliable of a node. But it can still be a potential one. So you may ask, well, okay, so we have this whole world of payments and transactions as packets, but how is it routed? And that's certainly an ongoing question. There are a lot of exciting discussions on mailing lists and otherwise on Reddit about how this may evolve. But what we're envisioning is something like a scale-free network. So the internet is effectively routed that way. So we're thinking of Lightning as a decentralized network. There will be some hubs that are more connected, or sorry, nodes, excuse me, than others. But ultimately, it will be like a scale-free network. And the really cool thing about Lightning, as you all know now, is you can have these billions of transactions per second. But then what about the users? Because while we went through a lot of complicated explanations here of good old Alice, Bob, Carol, Mallory. Does anyone know Mallory? She's the malicious one. But what about the user that's just getting onboarded and is new to this technology? Well, ultimately, a lot of this is going to be abstracted from the user. The user can have an app. The opening and closing of channels can be automated, and this complexity can be hidden ultimately from the person involved. The user can see that funds were deposited, and then we envision that blockchains such as Bitcoin can be a transfer layer for the value. And the user may not necessarily know this is happening. As you know now, the transactions for the user will clear near instantly, none of this 10-minute confirmation time type thing. Fees can be extremely low. Unlike with mining, say on Bitcoin, you actually have to expend a lot of electricity and energy in order to mine because of the way the Bitcoin network is structured. With Lightning, it's merely, kilobytes maybe, if that, in order to route or to send or receive. So then, machines can also have the equivalent of bank accounts. Machines can hold value when it comes to Lightning. Right now, if a machine wants to, have dollars in a bank, it can't quite go to the bank next door and say, here's my EIN or SSN, get an account. With Lightning, we can change that. So we talked a lot about Lightning on Bitcoin. So Bitcoin was the original kind of impetus for this. It is going to be the first use case for Lightning, and it's a very exciting use case. But Lightning itself can be blockchain agnostic. It can work on other blockchains. So in this case, we have good old Alice, Carol, technically Bob's in the middle there. We have two different chains. So Alice and Bob are connected via this bank chain. There are a lot of banks now that are creating their own blockchains. Bob and Carol through an equity chain, maybe an Apple stock chain. And as long as Bob in the middle has liquidity, on both sides, you can have what is called an instant cross-chain atomic swap. So in this world in which a lot of different financial institutions are creating their own blockchains or digital ledgers, there's going to need to be a medium through which those ledgers can be connected. You also may have different consensus rules on these chains and they may not be compatible, but Lightning can actually, again, be the layer that connects them. And so, again, Bitcoin being the first blockchain, but other blockchains can use Lightning too. Even in a world of permissioned ledgers, you may need the ability to have instant transacting. It can be inefficient to maintain that global state where every node in the network knows about every transaction. The computational complexity of synchronizing the shared state can be, high, so you want to minimize it. And then if you want to make these cross-chain payments, it can be way more effective to have a Lightning type structure than to have custodians or clearinghouses where they have to have the, say, legal or even the technical risk of having custody because, well, if you have a lot of, assets in one place, what we know with Bitcoin and digital currency, it's probably going to get hacked. So there are a lot of really exciting use cases, and this is part of what got me really interested in Lightning. So naturally, micropayments. Right now on Bitcoin's blockchain, the fees are about 5 to 10 cents. So it doesn't really make sense to have a 1 cent payment because you're going to pay a fee of like 5 or 10 cents in order to do so. With Lightning, you can have very low payments. A Satoshi, which is way below a cent, potentially even sub-Satoshi. We can get into that later. And the fees can also be very low. So you can envision a world in which you're browsing the internet with your phone or your laptop, and every time you see, say, a video or article, you can automatically pay, say, 5 cents. Again, machines can have bank accounts, so you can have machines that automatically pay other machines. You could, say, pay for every second that you access the internet while you're traveling, or have a mesh network of sorts of phones or devices sharing those. You can have what are called multi-party smart contracts on Lightning with an escrow functionality. There can be marketplaces where a variety of participants want to ensure that they receive the goods and funds are held in escrow. And Lightning can enable multi-signature contracts related to that. You could pay for coffee. We're not thinking that coffee is going to be the initial use case for a lot of this. One of our vision, you can already kind of pay for coffee right now with other means. But one thing that's really exciting about Lightning is it enables use cases that are not yet possible. You could have arbitrage between a variety of exchanges, either in Bitcoin or other assets, where you can then instantly send between exchanges. So you can ensure that if there's a price differential, somebody can profit off of it and make money. And then really, interestingly, you can have a world where there's an entire decentralized exchange. There's a network of these transactions as packets, where the variety of the participants can have different assets. And then on the network, you can find the best exchange rate between them and have these instant swaps. So automated payments is one of the use cases that we're really excited about in the context of Lightning. You can have a logic around payments and set payment policies. So one example would be, I'm browsing the internet and there's a video and I can either wait 30 minutes to watch it or pay 5 cents. Well, I'd rather pay 5 cents than watch that ad probably. And this can be automated, so even as a user, I can have a policy where I just say, okay, pay 5 cents when I watch a video, so I don't even have to click a button. And the cognitive overhead can be high for the user if you always have to click through, but when it's automated, it can work a lot more efficiently. You could have servers that automatically decide with other servers, okay, if the server has 10 gigs of space, you can auto pay $5, copy all the data over. You can have services where you pay for each API call. You can envision a world in which you have competing API services. Then you don't need to provide them with your username and password. They don't have to collect all sorts of data on you that then might ultimately be breached, hopefully not. So you can decentralize the identity aspect and still have the payment authentication. There may very well be a world in which your drone pays your self-driving car at some point. Probably not yet though, but eventually that may well happen. So right now, our progress on building Lightning is we've gotten the most important change to the Bitcoin protocol called check lock time verify that enables the timeout functionality that we described earlier. There are 2 more changes. One is in progress called check sequence verify, and segregated witness, being a very important one, is in progress for those of you involved in the Bitcoin community. It can enable outsourceability, in particular of when there may be a scenario in which somebody could broadcast an outdated state and try to steal your funds. Well, other services can then go and broadcast transactions on your behalf, and as a penalty, you will get all of their money. So there's a disincentive for the participants on the network to ever try to cheat you because they're going to be penalized, and well, our goal is that that doesn't have to happen, but the safety is always there in case somebody tries to do so. We have a team, 3 of whom are here this evening. We also have an amazing developer who's based in Santa Barbara, who's moving up here, working with us, and we have code up on GitHub at this URL, github.com/lightning network. The protocol is totally open source. Our implementation is up. It's written in Golang. Check it out. We love contributors. We're working on some facts for people that want to get to know our technology and otherwise. So yeah, I think that's it for us. Thanks so much. I think we're doing Q&A and panel, right?
Thanks, guys. Thanks a lot for sharing with us your progress, and look forward to growing this as a community from 4 to a lot more. So maybe I can start the Q&A with a question from my side, and I'll probably ask the $6 billion question. Bitcoin is going through a lot of changes this year, and those of you who have been tracking this consensus around how to scale Bitcoin and different schools of thought around that. And clearly 2 large schools of thought that have articulated their points of view quite a bit. One around seeing Bitcoin as a pure consensus provider, and seeing structures like Lightning and others as providing the vertical applications on top of a pure consensus type of service that Bitcoin can provide as a layer. And the other school of thought, which is seeing Bitcoin as a payment network and looking at how payments as the core application which led to the creation of Bitcoin, how can payments be scaled on its own? And of course, they've got names. One is called Core, the other is called Classic. Would love to know how you guys weigh in on this debate, and what you see as the pros and cons, on these 2 schools of thought.
I'm just curious, show of hands, how many people here have heard about the Bitcoin controversy, or like Bitcoin is dead, or like the developers are all leaving? Okay. So much like earlier, we are non-political as a group, a company, and a team. We don't take sides in these debates, but we really see Lightning as providing a key function of being able to scale blockchains. Even if you go from 5 to 10 or 20 transactions per second, well, if you're going to be able to do thousands, hopefully at first, going to millions and onward, that's a huge, increase in scalability. So we see our goal as really providing a solution, no matter, which team you're on in terms of the recent kind of drama.
Yeah, to reiterate, I don't. There's basically no way to have decentralized consensus with millions of transactions per second with a globally synchronized network in a feasible sense. To be able to achieve that, you need to think in layers and think in structured ways that make sense. We're shooting for millions to billions of transactions per second, and Visa only does 40,000, right? That's what you really want. If you want to do paper API, that's the numbers you need to look at.
Someone the other day was tweeting, "Oh, well, Bitcoin can never get to Visa level," and I said, "Yeah, because we're going to exceed it."
Yeah, I mean, a lot of people have been arguing about scalability of Bitcoin forever, 7 years or whatever. And I think the Wi-Fi access point is a good analogy. You might make a really fast, 60 gigahertz Wi-Fi AP or something. Okay, 10x, maybe 100x, that's about all you're going to get. So you do need to segment in some ways to really get to millions a second.
That being said, you need the base layer to work, and that may result in block capacity increases in various ways.
No, a faster access point is better. So do whatever you can there, but just having that's not going to be enough. So.
Yeah, so since you said everybody's transaction is visible to everybody, I know what is the total amount available there and the rate of growth of the money in Bitcoins?
So in Bitcoin itself, you're asking about, or? Yeah, so Bitcoin, a block comes out every 10 minutes. It used to be 50 coins per block, now it's 25. So the total, it's sort of this decaying function where you asymptotically approach 21 million total coins that have been issued. So everyone who runs the software validates that, yep, there are only currently, 15, 16 million or something. So everyone knows exactly how much money there is and where it all is at all times. In Lightning Network, you will also be able to see, okay, here are all the channels. To some extent, you don't really know if it's a channel. But you don't know within Lightning Network where these payments are flowing by looking at the blockchain.
Yeah, thank you. So as a company, strategically, what do you see your main goal in 2, 3, 4 years? Is it solving the scalability problem of Bitcoin and number of transactions, or applying this technology to remittance and money, like not cryptographic currency payment network?
So our first goal is to make Bitcoin great again. I don't actually support Trump. Our second goal is, I think there's a lot of applications for cross chains, and I think as an organization, I think there's a lot of opportunities there.
Cross chains?
Yeah.
Is this working? Can you guys hear me? Okay. We basically want to, reinvent the entire financial system. No big deal.
I have a question. So this check sequence verify is basically like a relative thing. So once the transaction hits the blockchain, then it basically starts counting when it gets.
Yes.
When I can redeem it, or is it?
So if the parent transaction has an output that has CSV, let's say 20 block and then CSV, the child has to be at least 20 blocks after.
Okay.
So you can set conditions within an if statement. So if 1, if 0, then you have to wait 20 blocks plus some other conditions. If if 1, then you can, then it has other restrictions, like a different signature type, for example.
Yeah, if you don't have a relative check lock time, when you create your channel, you have to decide on the duration of the channel at the outset. If you have a relative lock time, it can be, things spending from that channel are relative to that transaction. So you can basically leave your channel open for as long as you want, and then you have relative timeouts afterwards closing it.
Yeah, so the fun thing is you can just leave a ledger entry on the blockchain. The channel's open for years on end, and all you see is just one ledger entry.
Okay, so exactly that was my question. Like, what happens if you have a transaction which you have signed by the counterparty already, but it you said like a year basically redeem time, and now let's assume the Bitcoin price drops dramatically in that time, and the fee that was originally in that transaction now is not enough for the transaction to be broadcasted and put on the blockchain, so the miners won't mine it.
Okay. One thing is fees don't change determined in Bitcoin. If you look over the last, they've only gone down. If you look over the last couple of years. So if the price of Bitcoin goes up 10x, then your Bitcoins are worth 10 times more in dollar terms. But in fees, like Satoshi per kilobyte, it's basically never gone up, right? I mean, maybe a little. It's gone down. It's been just going down.
I mean, my example, the price goes down, and now the amount of the fee is not enough for people to mine your transaction. So I had this transaction, but nobody.
Okay, let's disassociate that and assume it happens because prior history and stuff like that. The thing is, if the fees for the older states are too low, you shouldn't be broadcasting the older states anyway. You should only be broadcasting the most recent one. So just refresh your channel with whatever the applicable fee is.
Nobody will countersign my transaction.
Yes. And if they broadcast the older one, and let's say the fee was too high, you're taking all of the other guy's money if the other guy's a jerk anyway. So it's not that big of a deal.
I guess your question is sort of like if you've had this channel open but unused for a year somehow.
Yeah, the guy disappeared, but I cannot.
Basically the software will automatically close channels after a certain period. You don't want a channel that you've not been just sitting there for a year because there are some various risks.
I think we have more.
Yeah.
So it sounds like a lot of the things that the Lightning Network is enabling are transaction types that are impractical today on the Bitcoin network. So
on any payment system.
On any payment system, so that's fair. So when we look at this, and we talk about it being a scaling opportunity, what current types of Bitcoin, in other words, the scaling problem is with what we can do today, we can't scale to meet the demand. With this is dealing with a whole new class of stuff. And you're going to be settling to the blockchain. So you will also be adding transactions into, a new set of transactions that never existed before.
Only when you enter and exit the blockchain.
Right.
Yeah, so it's just one small transaction to enter, and let's say several years later, one small transaction to exit.
There could definitely be a Jevons paradox kind of thing where, okay, this makes Bitcoin transactions much cheaper and faster, and so way more people start using it, and so actually there's even more contention for block space. That's kind of a problem, but also it's kind of a cool problem to have for the whole network, right? Okay, now way more people are using it.
And so it'll meet your initial objective, which is to make Bitcoin great.
Right, well, so I think, it's interesting because a lot of the internal community discussion around Lightning has basically been, okay, Lightning, can scale Bitcoin for what it is today, but part of our goal for this technology is to really bring the new use cases that aren't yet possible yet. And you're right, we want a lot of people, maybe not even great again, but we'll stop referencing that. But a lot of use cases that you can't have on a 10-minute confirmation time, 5 transactions per second, or similar order of magnitude network. So as a result, we probably will see more transactions on the blockchain to open and close these channels. And I do believe that the community will be able to adjust accordingly when it comes to that.
So the fun thing is that you're going to be able to do stuff that you've never been able to do before, right? You can't reliably send a one-time payment that's equivalent to 1/10 of 1 cent, right? There's a lot of interesting use cases for that, and you're not able to do Visa charges 29 cents PayPal charges 30 cents for payments of goods and services.
But this is the point.
Yeah.
Like if I think of ad networks,
Yeah.
and I think of the number of transactions that are effectively happening on that.
Oh, yeah.
And I look at it in this way.
It's per view, yeah.
Yeah, but I still see that open and closing may be the only transactions going to the blockchain, but you're still going to have a lot of those, even though you'll have millions more of the actual Lightning Network transactions.
Yeah, the
but there's
base
still a lot
layer,
of
the base layer, you still need to be able to support these entries
Yeah.
and exits. And fundamentally, this helps you get around unlimited number of transactions.
Yeah.
But the blockchain is basically a per participant view. So it's sort of, it becomes, the blockchain is sort of like a switch network where the circuits.
Yeah.
And above that, Lightning is per packet. So it's sort of, how many people you can support instead of how many transactions.
Yeah. So I think check log time verify is there in the protocol, but CSV I believe is not yet, right? And then what changes will still be needed, or like will be hopefully have to be helpful in a protocol?
Yeah, so segregated witness is the most important one, simply because it resolves a lot of the long-standing issues with Bitcoin, and it helps in order to make those refund transactions. It's functionally fixing Bitcoin's biggest bug since inception. That's what it's doing. And this needs that bug to be fixed, and that'll go in around summer time.
Well, you can run Lightning with just Bitcoin as it is today, with only check lock time verified, but there's a lot of limitations. The channels you sort of double your transaction sizes and signatures, and then also your channels have a limited duration. So it can be done with Bitcoin as it is today, but it seems very likely that segregated witness will be merged in the next few months, and so our code is based off of that work.
Yeah, our goal is to be able to use Bitcoin's blockchain, to the greatest extent possible. So ideally, we want all those changes then to be there so that Lightning can be cool. Lightning can be great again.
It's always awesome.
So no other change of the segregated witness?
There might be a couple, but
There's
this
always
is
like little optimization.
You can always make things better, but when it comes to making it work well, I would say that's what it is. I mean, I'll be commenting on other stuff later.
And we're actively, in touch with the community that's involved in the development of the protocol, and giving them feedback and ideas, and potentially proposing some things too.
Hey, different currencies fluctuate differently, and sometimes you can short the currencies of Britain or US, and since even this is publicly acceptable or traded, since if it goes up or down, is there any way to trade it to go to make money out of it, or it's only for the insiders who can do it?
What do you mean by trade and make money on it?
The value of the bitcoins goes up and down, so.
Oh yeah, you can trade.
Yes, so one example of trading on Lightning that you can do, well, with Bitcoin, let's say you wanted to arb between two exchanges, and let's say there's a price difference. Well, there's a block confirmation time, right? You have to wait 10 minutes per block, and most exchanges require 3 to 6 confirmations, somewhere in that range. You want to be able to instantly transact. The cool thing about Lightning is if you have channels open between them, and they all supported Lightning, you can move money pretty much instantaneously. You can keep a zero balance locally on your channel, so you have no currency exchange risk. Let's say you're an API service, and someone pays you some measure of amount of Bitcoin, but you don't want currency risk. Well, you immediately send that up to an exchange it for US dollars or whatever you want.
Do you mind? Sorry. It's okay, sorry.
Yeah, I'm just still struggling whether there is an actual advantage of going this route. You said like Visa, for example, that's 40,000 per second. I mean, is that because that's all we need right now?
Okay, Visa, you can't atomize all the payments in the world in the sense that you can't transact, a tenth of a cent.
I mean, I hear that.
Cases for that are dramatically different, and it's sort of like, look what happened with HFTs, right? What happened was before you had 50,000 shared block trades, and what happened was there were people like Bats, people like Island. people that really started decentralizing the system and making it extremely low fees. What happens when you make things extremely instant and extremely low fees is transactional volume goes up dramatically, and the transaction value size per transaction goes down dramatically. Right? So it's like 1 to 9 share trades, hundreds of thousands of trades.
So one other point is I can't, as a developer, easily develop an application using Visa's protocol. There are a lot of restrictions on that. What Lightning can really be is this the financial protocol, protocol of value, similar to say an SMTP. People will build a Gmail type application on top of it, but Visa right now is really its own network, and you can't just easily tap into it. And also, I can't really receive payments over the Visa protocol. I mean, well, you could theoretically use Square Cash, and then they use a debit and all of that. But the ability for anybody to build on top of this and participate is much more internet-like in that sense.
But I mean, I understand that part of it. But if I'm just talking strictly from a technology perspective, if Visa were to open up, I'm just saying the system exists. They are right now choosing to charge 29 cents. Yeah. Is it really costing them that, or is it really excess spread?
The issue is that they're custodians, right? Why are they charging 29 cents? Why don't they make it free, right? The reason is because they have a 1-800 number, right? With this is all non-custodial, right? You hold the money similar to how you hold your cash in your pocket, right? There's no 1-800 number. It's your money, right? With Visa, if let's say there's a dispute, there's someone to call, there's someone to sue. And that's dramatically different. So custodians change the game dramatically.
I'm calling you.
Visa probably could do 10 times more transactions. They could segment that in their network too. That's not really I don't think Visa is going to try to use Lightning Network blockchain stuff. Maybe, but with trusted, we'll build it for them.
No,
but that's not really the core cool part about it is that hey, there is no 800 number. You're just programming it yourself, and so you really have control over that.
So one more question about in the payment channel, right, the establishment of channel and the takedown of channel goes on to blockchain, but in between those transactions does not. So there need to be a off-chain methods to send that transaction. So in your particular implementation, what do you use for that? And also the addition to that question is how do you do the routing and then those kind of.
So. There's another layer. It's not port 833. Bitcoin's peer-to-peer network operates on port 8333, has its own message protocol. We have our own new message protocol for Lightning that's on a different port. It's encrypted and authenticated because each Lightning node does have sort of an identity, unlike Bitcoin nodes, right? Because you do care with Lightning who you're transacting with, whereas in Bitcoin you don't really care. They're just sort of anonymous. So that's kind of a nice thing to put encryption and authentication on top. And that's mostly written. It works, but we're definitely still working and expanding it.
Then in that case, how do you have to broadcast your ID of the?
It's all just direct.
Do you have to?
It's just IP connections to each other.
To each other, then how do I know that I can? How do you have to advertise that I'm willing to accept being a one of the.
Well, initially the way it works
is
initially the way it works is if you're paying someone, instead of sending a standard Bitcoin transaction, you just open a channel with them. You can add additional funds in there, and you're going to get your money back.
So the addresses are just Bitcoin pubkey hash at IP address. Or
right. Because you have to route them, right?
Yeah. So additionally with routing, there are structured ways you can go about it. It's something which is an open exploration. And there's, I think, a multiple strategy view is the correct view. An example routing strategy would be you provide a list of routes, multiple paths, and then the recipient provides multiple paths, you find an intersect, and then that is your route. So that's an example. Yeah, to the recipient.
It's not propagated. It's not. You only talk to the guy you're talking to. So you're not saying hey, here's a message, send this to your friends. It's just sort of here's my state, okay, here's your state, and we find matches that way.
Yeah, I have a question for the panel. When was money invented?
A couple thousand years?
Well, it depends what you define as money.
Currently, 1971, right?
I mean, a lot of people attribute like Mesopotamians, right? It probably goes far below that, before that with seashells and things like that, right?
You should read Nick Szabo's Shelling Out. That's a great article.
Awesome read.
So they say 700 BC and maybe before that, but my point is, like, you guys are all obviously amazingly talented people and trying to solve, some problems that really exist. So when do we, instead of trying to go full force into the hurricane, try and find, a bit of an angle to get some leverage on the problem? I'm an angel investor from China, we do a lot of global fintech investing.
So
it feels like you're apologizing for whatever. I hate the apologies because you're solving some real problems, but how do you get an angle on this that can really get move forward?
I think historically with Bitcoin, what we've been doing is we've been replaying actually the history of money, and we've been replaying it without custodial trust, and we're just doing it better, right? Throw computers and networks at it, you can do cool stuff. Much like the internet rewrote the history replayed the history for information. You had people going through it. It looked like repeating the steps in a way. We were like, what's the point of this? We're sort of at a point where we're hitting maybe the 1800s, right? But it's not present day yet. So it may seem a little bit like, whoa, what is this for? I think with Lightning, you are seeing some glimmers, and I think we explored areas which we weren't able to do before, things we weren't able to do before. You may see dramatic expansions of that, in the coming years ahead.
And similarly, we're kind of reinventing the internet too, and right now we're basically in like 1993 or 94. So we're, people are saying, oh, there are no use cases. Well, our view is, well, Lightning will bring those use cases, and we'll get the World Wide Web and all the things that came about.
I have one more question about the routing system. So you talked about you have your own port and stuff like that, which works perfectly if you have a server which has its own IP address and no nothing. If I have my phone and I'm running the software on that, how will that how can I reach that from outside? How do you do the routing?
Yeah, so you can, much like how you can delegate a relay server. So you have a relay server if you're not accepting outside packets, then you have a relay server and you designate that relay server as your recipient. Yeah. I mean, it's end-to-end. It's end-to-end, yeah.
Hi, I think you guys are way ahead of all the governments where they're trying to do cashless society. But then I think in comparison, I think you guys are like PayPal with debit cards only, if I'm stating right.
Well, you could use this for a lot of stuff. I think, payments are sort of the first step, and it's the most easy win. So that's the examples we're giving.
But, as per the cross-chain, stuff I talked about, you can envision a world of high-frequency trading on Lightning and the instant swaps, and you can have all sorts of other assets. So really, Lightning becomes a protocol for value, and then you can have any kind of value represented.
So like in P2P networks where there can be superconnectors, is there going to be a superconnector as a service opportunity off of Lightning?
So, in P2P networks, the common term is super nodes instead of hubs, because hubs are, it's not like a UPS or FedEx hub or Tennessee, they just have one, right? There will be nodes that are more highly connected, I think there will be probably hundreds to maybe thousands of them. The entry cost to be one is effectively zero. So what kind of real economic rent are you going to derive from that? Probably nearly zero.
Well, it is a cost you have to put.
Yeah, you have to put Bitcoin.
Bitcoin.
Yeah, so you have to put up you have to put up Bitcoin, so it's not free for you. There is some time value for that, and everyone else can be able to do this, and it's not custodial, so you're getting money back. It's sort of like if the gold lease rate was non-custodial, what would that interest rate be? Probably close to zero.
The other aspect is a lot of people that we've talked to have a bunch of Bitcoins, like this idea. They're like, I'm going to make money by routing and charging fees. And it's like, you might make a little, but a lot of people have also had this idea. And so there's going to be a lot of people who are like, yeah, I have a server, and I have some Bitcoin, and I'm going to route. And so there's going to be a lot of competition. It's probably going to be a lot worse than mining. And mining is a very similar thing, where there's a lot of people who are like, I'm going to make money with my computer by mining. And in a lot of cases, it didn't work out because, well, everyone else had that idea. Everyone bought, the hash rate went up 1,000,000x or something. And a lot of people either lost, they didn't lose, they didn't make the gains they were hoping for. So I caution a lot of people, like, hey, I'm going to get a lot of Bitcoin, I'm going to run servers and route payments. It's great, that helps the network, so I don't want to discourage it, but I would say, like, you're probably not going to make much money, which is good for users of the system, because it's going to be very competitive.
Which makes the transaction really, really cheap.
So do we call you guys a sidechain?
No.
No.
These are all real Bitcoins on real Bitcoin transactions, and there's real ledger entries on Bitcoin.
But so is a sidechain. When they freeze the coin, move it to the
Well,
side.
okay, so one way that I typically distinguish sidechains for those, and I know Adam back gave a talk, is that the sidechains have an asset issued on them. So Lightning is always just transactions of that particular blockchain where the state is updated locally, as opposed to a separate chain with a separate asset. Sometimes that asset may represent the asset on the original chain. It gets a little complex, but Lightning is different in that regard.
Sidechains enable, like, the primary value of sidechains enables you to do like exotic, complicated like scripts, or put on different assets or something like that. In this example, this is pure Bitcoin. You could envision a situation where you had a separate asset issued, you wanted to interchange Bitcoin with that sidechain asset, you could use Lightning for that.
I think the main distinguishing for me is in Lightning, if all other parties except for you, as long as the blockchain is still working, if everyone you're connected to goes down or turns evil, you're okay. You don't lose a single cent. Whereas in sidechains, there are a set of sort of operators of the sidechain. And if they all turn evil, well, you're in trouble.
But in pure Bitcoin, there are scripting limitations. You can't, for example, issue an asset natively in Bitcoin. So with that, you may need some type of sidechain type construction, and then you exchange Bitcoin with that inside the Lightning channel, inside the sidechain, and then outside the sidechain, and then you trustlessly swap between them.
Excuse me.
Sorry. So if the nodes are not going to make any money off it, right?
They'll make some money.
Right, but so the incentive there is like that little money, or because they're also using the Lightning network themselves and
both. If you as an individual have, if your phone, let's say, has 5 channels open, you can route on your phone, no problem. You may be able to collect some small amount. And the user's obviously doing that to have 5 channels. They're not doing it to make money, but not make a little bit.
So you compared it a little bit to the mining ecosystem, right? So do you see a possibility that we'll see like a similar kind of centralization in terms of a few very big nodes?
With mining, there are significant network effects at play, which, functionally, because you are dealing with real things, tangible things, there are economies of scale. There are, geolocation benefits.
Data center. With this, your desktop can route probably thousands of channels. So like if okay, and even if you're like, okay, I'll buy like a 2U rack mount server and I can handle like hundreds of thousands of channels. So you're gonna have it pretty decentralized. It's gonna be hard to get to that.
Because like Visa does like off peak capacity, they do like somewhere between 10 and 20,000 transactions per second. Your desktop can probably do that on Lightning with the way we're designed.
And so, unlike with mining, as I said, every node in the network, which is every participant on the network, has the potential to route transactions. And unlike with mining, where you have the substantial electricity costs due to the way that Bitcoin itself is mined, you don't have that with Lightning, so it's really just a few packets of data. We don't foresee that there's going to be a world in which you have. We don't foresee a world in which you're going to have, a huge centralization. That said, you will see some nodes. They may be a payment processor. They may be a startup that's doing, pay-as-you-browse content payments. That will have some more connections through it. But no, I very much do not believe we're going to see this similar situation with Bitcoin mining as we will with Lightning.
And Lightning is non-custodial, so the reputational value is extremely low to non-zero, pretty asymptotically close to zero. With mining pools, there is some measure of trust that you ascribe to them because you're sort of like giving them hash power before they deliver you your money, right? So with that, there is a certain measure of trust involved actually by individual mining that has very low hash power.
Yeah, so since you guys charge some fee, right? Do you have a minimum?
We don't charge.
We don't
charge the
network. Yeah. So is there any minimum transaction amount?
1 Satoshi.
1 Satoshi is a theoretical limit. You can go below that.
And 1 to 13 is a what, like in cents? Like it's like how many?
It's like 1,000.
10,000 of a cent?
Yeah. Yeah.
Pretty small.
10,000.
And you can go below that.
Yeah.
You can trust this. I'm gonna give a talk about it later. There's ways to probabilistic.
So when you want to do things like pay-per-view or even paper ad impression or something like that, you can do these types of things because the minimum value is just so low. Like we're talking paper kilobyte, paper second, things like that.
This is the last one.
You just said like for the mining pools you get basically paid before you trust them that they pay you later, right? But what you can maybe with Lightning also do, like you have a payment channel, Lightning payment channel with your miner, and then you reveal the hash of the solution of the share you have, and then you pay at the same time.
Yeah.
Instant paper share. Yeah, you could.
Oh, I get it. Okay, great. Last question.
Last.
Right.
Thank you so much. I'm just learning about all of this, and it's really fascinating. I'm wondering, and I'm trying to pull together different worlds and see if there's a use case here. Is there a way for micropayments for data? Say in industry, you want to pay oil companies, refineries, or farmers for reduced emissions and greenhouse gases, or really anything, and then to support that, and also to support the transparency of that, you make micropayments for that, and then when you go buy the product, there's also additional payments, obviously. I'm trying to see how those worlds could come together.
Are you talking about like batching and pre-allocating individual payments together into many different participants? Is that what you're saying?
I'm not that technical. I don't know what that means. But I just want to support a world where, say there's a refinery and they're reducing greenhouse gases or air pollution or whatever, and I want to be able to have like an interface and see that and pay for it, like micropayments for that.
What it does get you potentially is you can have sort of non-custodial, what do you call it, like auditors or like someone. So let's say, if you want to do that with the current financial system, you can say, okay, I've got someone who comes in and inspects this, power plant and sees how much CO2 it's putting out, and they essentially have the funds, they have custody, and they decide where money goes. You can have sort of these third-party auditors or inspectors who decide where funds go without ever being able to touch the funds through use of multi-signature or constructions like that. So it can help that. That's sort of probably further out in terms of like smart contract functionality, but there are definitely like ways it can help with that.
Oh wait, you don't need auditors because of industrial Internet of Things, sensors attached to all of these devices.
Yeah, you could audit that.
You could make it per payment. Your individual payment goes to 50 different participants, so that like when you buy a good, the payment is conditional on paying these 50 people. So you go down the supply chain, whatever it is.
And yeah, with those use cases, of course, as we discussed, you need to be able to say authenticate whether the emissions have reached a certain level or have gone, below, or depending on if you want to reward people or you want to punish people. And Lightning wouldn't necessarily deal with that, but assuming you trust the Internet of Things or the various sensors that detect it, this can be a protocol where you can have those types of micropayments. You can envision shared energy, where you could have solar panels on a variety of buildings, and then you could have payments that auto pay for the use of electricity and energy between those. So there are a lot of potential use cases. Any use case in which you could have payments or transactions that would need to flow between participants.
Awesome.
You look excited.
So from coffee to clean energy to farmers, we've seen quite a bit of spectrum of use cases. So join me in thanking Elizabeth, Joseph, and Tadge for the wonderful talk and the great lively discussion. So we're going to be posting the video on our YouTube channel in a few days, and with their kind permission, also share the slide deck with you guys. Also,
we're good.
thanks a lot to Pivotal for hosting us here today, and all our sponsors who make this happen. And all you guys, thanks so much for driving up here and the wonderful participation. See you guys next week. Bye.